Okay guys, welcome back. One more week, Enterprise Network Security Automation, or Advanced Network Management, if you prefer that. So module number 2, we're going to talk about single area OSPF version 2 configuration. Alright, so this is module number 2 in Cisco Networking Academy. These are the main topics we'll discuss today. OSPF router ID, point-to-point OSPF networks, multi-access OSPF networks, how to modify single area OSPF version 2, the default route propagation, and how to verify single area OSPF version 2. We get started with OSPF router ID. Now, before I start discussing about OSPF router ID, let's just do a review of what we studied last week, mate. Do you remember what we studied last week?
OSPF theory.
Yeah. So what's OSPF?
Control first, it's the routing protocol.
Exactly. So it's a routing protocol. What does a routing protocol do, mate? What's the purpose of a routing protocol? Why should we care about a routing protocol?
It defines the method in which the routers change routing information between themselves.
Exactly. So we basically allow the routers to communicate with themselves and exchange networks. That's all this is about, right? So exchanging the networks. Basically letting the other guy know how to get to a certain destination network. This is how things work. Right? So the OSPF is one dynamic routing protocol that allows us to populate the routing table with information from a certain other router. So they talk to each other, exchange routing information that they know about. That's it. Alright. Now all these routers, as we saw last week, they will exchange this information, and every single router within the same area, they will have the same database. And there is a name for this database. You guys remember?
Link state database?
The link state database, or LSDB. That's called the link state database. Alright. Now, once all the routers, they have the same exact link state database, every single one of these routers, they will execute something called the shortest path first algorithm that will basically going to allow every single router to find the best path to a certain network. So you're basically handing out a map to every single router, and then every single router will make a decision of how they want to get there. You guys remember the example I gave to you last week? I'll give you a map to every single one of you, and I'll tell you a destination. And then you can make the decision yourself of how you want to get there. Exactly? So that's what the link state database does for the OSPF routers. So we talked about the area concept. All the routers within the same area, they have the exact same link state database. This is not good if you have too many routers, because that basically means your link state database will be huge. Alright? And it's going to be much harder for every single one of the routers to make a decision, because now they have too many variables involved, too many options, right? So if I make you choose between A and B, it's much easier than for me to give you 100 choices. Yeah? So that's the concept behind the areas. And that's why we use something called a hierarchical design in OSPF. Remember? So this basically means we're going to have a reference area, which is area 0, also known as the backbone area. Alright? Now, this area is extremely important in the OSPF hierarchical design, because this is the only area that can inject the optimal routes from one area into another area. So that basically means area 0 is the area that holds everything together. Right? Now we do have some routers that stay in the border of the areas, because after all, one router can participate in many OSPF different areas. That's called an area border router, because it's right in the border between different areas. But for a router to be an ABR, it has to have one of its interfaces in area 0, which is the backbone which connects everything together. It's like literally where everything connects. Alright? It's the reference point. Cool? It's like the city center where everything converges to.
How many, in the real world, how many routers are you talking about being too many or not? How many would you have in an area?
It's not too much about the number of routers, but also the number of networks as well that you are sharing with the routers themselves. So it's just basically a matter of, trying to run in a single area, observing the performance, and if it's just too slow, you can then segment your routers into different areas.
Are you talking 5 or 50 or 100 or?
In terms of networks or routers?
Oh, well, either really. You know, like are the areas like quite small, like, you just usually, like
Yeah,
5
the areas are usually between 5 up to maybe 50 routers. Yeah.
Okay, yeah, right.
More than that, better to separate things.
Yeah.
Alright, so now we keep discussing about OSPF, and now we talk about something called the router ID, but something else as well. So last week we also saw that a router can be an area border router, but it can also be a specialized type of area border router, which is just basically injecting external routes into the OSPF domain. What kind of route is that?
SABR?
Autonomous System Border Router, or ASBR, right? That's basically your autonomous system border router, and when we talk about the autonomous system in OSPF, it's basically all the routers running OSPF within what we call the OSPF domain. That's it, right? And usually these ASBI is connected to the ISP or something else, or to another segment of the network running a different type of routing protocol, such as EIGRP or BGP, whatever. Is that clear? Cool. So now let's talk about the router ID. Now the router ID is basically what the routers uses to identify themselves. Because once they need to exchange this information, you need to know where is this information coming from. And one way you can do that is by identifying the router that is advertising certain networks. Right? And OSPF does that using something called the router ID. So it's just basically the identification of the router. Cool? And we'll see that we can actually configure the ID for the router, or we can let the router assign itself an ID based on certain criteria. All right. Questions so far about OSPF? That's it? Cool. Now, OSPF reference topology that we're going to be using here is just a very simple one, area 0. All these routers connected to the backbone area. We got 3 here. Every single one of them have a loopback interface. Okay. Now, do you guys know what a loopback interface is?
Virtual interface.
Exactly. Now, one important thing about the loopback interface is that it's an interface which is always up because it's virtual. So it's not tied up to an interface which is physical. So even though there's nothing connected, it's still up, okay? Because it's actually inside of the router itself. It's like a virtual interface in the router itself. It's extremely useful for testing purposes. So you don't have to keep plugging in any devices to the router. So you can just use a loopback interface on the router, assign an IP address, and you can use that for testing purposes. All right. Here we have one, another one here, another one here. Okay. So we assign an IP address to the loopback interface of the router, and then we can share that information. So this is the topology we are interested in. What's the name of these router here? It's R2, but in terms of OSPF, what type of router is this?
Mean whether it's like a Droder or a
ASBR? ABR?
ASBR.
Why?
connect to the ISP.
Connect to the ISP. So you have an external connection to something else which is not your OSPF domain. Alright. Now let's check this out. So this is the basic command for us to configure OSPF. Now that we know how OSPF works, how the routers exchange information, how do we configure it? Okay? Extremely simple. With this command router, we can configure the routing protocols available in the iOS. Okay? We have to be in global configuration mode. We type it in router, you get a whole bunch of options. Router OSPF, router EIGRP, router RIP, and router BGP. They are all within the router configuration. Is that clear? Yeah? Now this one here, we're basically creating router OSPF, so we want to use OSPF obviously, and we have a number here, number 10. What is this number 10? Is that the area? What is that? This is something called process ID. Process ID. Now what you have to keep in mind is that the process ID is locally significant to the router. So only the router knows what the process ID is. Why is that? Because you can actually configure multiple instances of OSPF in the same router. Okay? That's why. So you can run multiple instances of OSPF in the same router.
In what sort of situation would you run more than one instance?
I've never seen any.
Border.
I have never seen any. Usually it's the same instance, that's all.
What
And-
about that border router?
No,
Border
you can
router.
still have the same instance.
Oh, is it?
Yeah, maybe if you had a separate, like, security network that you wanted to keep separate from.
Could be, yes. Yes. That would be one application. And if you want to keep things separate, yeah. Alright, now we also have a whole bunch of other options here for our OSPF configuration. The area, the autocost, which we're going to talk about, default information, where we're going to configure the default route propagation within the OSPF domain. We have the distance, so we can play with the administrative distance of OSPF. Does anyone know the default administrative distance for OSPF?
110?
Yes. Then we got the exit, so we can leave the mode, and a whole bunch of extra options. Another one which is important here is the network command. The network command will allows us to create a list of the networks that we want to advertise. Because once we configure OSPF on the router, you still need to tell the router what does the router need to advertise. The router is not going to advertise everything just by itself. You have to tell the router, okay? We also have the command called passive interface, which we'll discuss today still. Redistribute command to redistribute external routes, and router ID to set up the router ID manually. Alright, so let's talk about these router ID. This router ID looks like an IPv4 address. Looks like. Don't forget that, Noah. Because it is not an IPv4 address. It looks like it. Why does it look like it? Because it's also a 32-bit number, okay? And you can represent it as a decimal number, for example, 0 all the way 65, 535, or you can actually represent it as an IPv4 notation. For example, instead of having area 0, you can have area 0.0.0.0. Alright? So you can have something like that for your router ID. Cool? Is that clear? Okay, every router requires a router ID to participate in OSPFs. So this is a requirement. All the routers, they need to be identifiable within the OSPF domain, because otherwise you cannot tell where certain network advertisements are coming from. Alright? So it has to exist. Now, moving on. Okay, cool. So about the router ID, there are actually many ways you can assign a router ID. First, manually, with the command. So you go into the router configuration, router OSPF, instance ID, and then you can assign the router ID manually to whatever you like. Second option, you can do nothing and allow the router to assign itself a router ID by itself. And how is the router going to do that? By just taking whatever it has in an IP interface and copying the IPv4 address as if it was the router ID. Oh, but the router can have many multiple interfaces. How is the router going to choose which interface? Should it copy the IP address and make it the router ID?
Takes the highest.
It just takes the highest. and starts with the loopback interfaces. If there are no loopback interfaces, get any IPv4 address of any active interface, and that's it. Call it a day. Done. Job's done. Okay? So if you have a router with two interfaces, loopback interface 192.0.1 and a physical interface fast Ethernet 0.1 10.0.0.1, and you don't assign the router ID, the router will just basically look at the loopback, get the IPv4 address of the loopback, and assign it as the router ID. Is that clear?
So does that mean that the loopback address beats the highest router ID rule? So it first chooses the loopback address,
Yeah.
and then after that it chooses the highest IP.
No. It chooses loopback first, so it's going to look at the loopback interfaces first. So if you have two loopback interfaces, you will choose the one with the highest IP.
Right. And
If
then
you just have one loopback, it's going to choose the loopback anyways. Alright? And then it looks up into the physical interfaces.
and
Only
whichever
if there are
one's
no loopback interfaces.
This is only if you don't set the router ID, isn't it?
Exactly. If you set it up, that's it. It wins. Okay? So the priority is whatever you set up will be the one. If you don't set it up, you will then assign itself based on the loopback interfaces first, and then physical interfaces, the one with the highest IPv4 address. Alright? So this is exactly what this is describing here. You know, because there's always a diagram for everything. But you start here, if the router ID has been explicitly configured with the command, that's what you're going to use. If it's not, the router is going to look at the loopback interfaces, and then if there are loopback interfaces, it's going to take the one with the highest IPv4 address as the router ID. If it doesn't have loopback interfaces, get any IPv4 interface and choose the highest. That's it. Right? There's always a diagram, man, you know. So there you go. So we start things off by creating the loopback interface. If you don't remember how to do it, we just do it by following this interface loopback. Once you execute this command, you create the loopback interface, ID number 1. Okay, so you can create loopback interface 2, loopback interface 3, whatever you want, mate. So you can assign numbers to the loopback interfaces. You can have as many as you want, as many as your router resources allow you to have, you know. And then after that, if you still run your OSPF in this router, you see that the router will take this IP address that you assigned to the loopback interface and choose it to be the router ID. And that's it. Is that clear? Alrighty. So here we have 3 routers. Router 1 uses router ID 111. Router 2, 222. Router 3, 3333. Okay? And then this is the command that we use to assign the router IDs if we want to do them manually. Okay? When I do it, mate, by design, I like to assign them myself. So for example, usually I assign router 1 the router ID 1111. You know, because it just makes sense to me. Router 2, 2222. And router 3, 3333. And whatever. Yeah? Remember, this router ID, mate, is not an IPv4 address. Okay? Is that clear? It's not. It has nothing to do with an IPv4 address. It just looks like it. Yeah? Because it's separated by octets. You got the dot, 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 dot. Looks like it. It's not going to be propagated in the OSPF domain. It's not going to be a reachable address. No, it's just to identify the routers. Okay? Cool. Now, this is how we modify the router ID. So if you change your mind, you had assigned the router ID to be something, but you then just changed your mind, you want to change it to something else. Remember that because the LSDB is now the same on all the routers, you have to do something to let all the other routers know that you have changed your ID. Okay? And we do that by executing that command, clear IP OSPF process. That is basically going to clear every communication that they had established with the other routers. And it will basically refresh the OSPF communication so that they will start communicating again. And then they will know you have a new router ID. Alright. Is that clear? So there you go, the command clear IP OSPF process. And then we can then verify that the router ID has been modified after that. Point-to-point OSPF networks. Let's talk about the OSPF network types. And the first one of them is the point-to-point. What is a point-to-point network?
There's only one start and one finish.
Yeah? You have how many routers?
Two. No, two interfaces.
How many connections?
One.
//2.
You got one connection, yeah, from one router to another router, two interfaces, one on each router. That's a point-to-point connection. So you know who is on the other end of the line. It's another router, for sure. And it can only be one because it's a point-to-point connection. Yeah? Now this is classic, mate. When you have this, there is just one router on the other end, there's just one router here. Why am I telling you this? Because we can have another network type called a broadcast. And what's a broadcast network?
Just an Ethernet network.
Yeah, but you have, that's one example of a broadcast network. But what's the concept of a broadcast network?
It potentially is going out to more than one other interface.
Exactly, potentially has many neighbors, yeah? Many routers connected, yeah? Somehow to each other, yeah? That would be a broadcast. And it's a broadcast because you have all these multiple routers and there is actually a way you can reach out to all of them at once. That's why it's a broadcast. Is that clear? Now, within these OSPF network types, we can change them. But this, we're gonna see how to change the network type later on. But this is how we actually advertise the networks. Okay? Now, every single router is connected to different networks. Isn't that right? You have many networks connected to a router. So once you activate the router to communicate using OSPF, you have to let the router know what is supposed to be advertised. And how do we do that? We do that with the network command under the OSPF router configuration. So you go, you type in router OSPF, and then you let the router know which networks is supposed to be advertised. Okay? I call that selective gossiping. Okay? Because you're basically selecting what you want the router to talk about. If it's not there, the router is not going to let the others know about it. It's that simple, mate. Okay, cool. Now, once we use this command, we basically need to enter something called the network address and the wildcard mask, followed by the area that it belongs to and the area ID. Now, what is a wildcard mask? Some of you may already know this, but some of you may not.
Reverse of the subnet mask.
Exactly. So it's the reverse of the subnet mask. What do you mean by reverse?
So normal subnet mask is start with ones on the left side and then zero on the right side at bit level. And wildcard mask is just zero on the left side and one on the right side.
Exactly. So it's the opposite. So you basically flip all the bits. Yeah. So for example, if you have a subnet mask 255.0.0.0, what would be the wildcard mask? 0, 255, 255, 255. So you basically flip the bits. If you don't like this definition, remember the following. The subnet mask plus the equivalent wildcard mask should give you the result of 255, 255, 255, 255. That should be the result if you add both of them. Now with this definition, you can just take all 255s, subtract the subnet mask, and this is going to give you the wildcard mask. It's that simple. Is that clear? This is just basically the reverse of the subnet mask. Alright. There you go. This is an example. So I'm basically advertising how many networks? 3 networks. So we basically activating these routers to communicate using OSPF, process ID number 10, and then we advertise the network assigning the area. So in this example here, all the networks that are being advertised, they are being advertised in area 0. So check it out. Okay. So which network is this? With the subnet mask notation. The first one.
Slash 24.
Yeah. Second one.
30?
It's 30, yeah.
30?
Third one. 30 as well. Yeah. Exactly.
Yeah.
If you can't see that, just do the reverse. So this would be subnet mask 255, 255, 252. Yeah. And 252 is /30. Yeah. And this as well. Exactly. Questions? Super easy, man. I'm trying to make it hard. Seriously. So there you go. Now remember, once you're advertising the network, you need to specify which area it belongs to. Okay. Now there is another way of assigning interfaces to the OSPF process, because after all, every interface of the router is in a different network. Yeah? So if I was your teacher for Introduction to Networks or Routing and Switching, I told you this so many times, mate. Every router interface needs to be in a different network. And why is that? The reason why this has to be this way, mate, comes down to the routing table. If you have multiple interfaces in the same network, the router doesn't know where to send the traffic to. Does that make sense? Yeah? The router just doesn't know. Because now it has many interfaces in the same network. So how is the router going to forward the traffic? He won't. And that's why every single interface of the router needs to be in a different network. Clear?
Yep.
Now because of this, you know, SPF, you can advertise the networks with the network command, but you can also literally go to the interface and tell that that interface is supposed to be participating in a certain OSPF process that you have just created before. So this is the other way you can assign interfaces to the OSPF process. So doing this and doing this is exactly the same thing. Here you're advertising the network, but this network is going to match the network that a certain interface is connected to. That's why it's being advertised. Now with this one, you are advertising the interface itself, so you don't have to specify the network at all. Go to the interface and advertise the interface.
Well, the submask, the wildcard is quote 0 in this example, right?
Yes.
So what does it mean exactly?
It basically means that that is a host,
Single IP.
a single IP. So this could be a loopback interface, another loopback interface, a loopback interface.
Okay, and I also vaguely remember, that we talked about an option to,
Advertise everything
yes,
in EIGRP. Here's the same thing as well.
so we can do it one command just to advertise everything.
Everything, the all zeros.
So that can be a physical interface as well, like, can't it? With all zeros.
What do you mean?
Because in the routing table, they have like /32s for the interfaces, don't they?
Yes, so some interfaces, they actually have one single IP address, which is the IP address of an end device. It's a /32.
Yeah.
It's just an end device IP address. It's a network with a single IP.
Yeah. So it can actually be the physical interface as well. It can be represented like that, can't it?
I'm not sure if I got the question.
Oh, yeah, no, you said it was a loopback one, but I think I used to get confused with the routing tables because they have like a /30 and a /32 for the same interface. And so I think.
Oh, yeah. I see what you mean. Now you get it. So in the routing table, you usually have 2 entries. One is the L entry, and the other one is the
Connected to
C.
C, yeah.
So usually what happens is one would be showing up as a /32 because that's the actual address of the interface itself.
Yeah.
So that is actually an endpoint IP address.
So it's a subnet of the.
But at the same time, it belongs to a certain network.
Yeah.
And that's why you got two entries in the routing table.
Yeah.
We're gonna do a backtrace and I'll show you that. And it will make sense.
What's the purpose of that no command? Removing the.
To remove it. So by doing this, I'm just saying, I don't want to advertise the networks with the network command. I want to advertise them by going to the interface itself and then typing in the command.
So it's like this is a continuation of the slide before, and they've just added networks, and now they take.
Yeah, and then take it down and
Okay.
go with the other options.
It's like they're doing a whole scenario.
Yeah. All right. Yeah, cool. So let's talk about this now. Now, once you enable a router to be an OSPF router, you then specify the interfaces or the networks you want to advertise. Is that clear? That's what we did here. You specify which area you want to include them in, right? So that all the routers in the same area, they have the same link state database. Now the thing is, mate, not sometimes, but most of the times, you want to advertise the interface of the router that is connected to a local area network. Isn't that right? So
Yep.
you have a router connected to a local area network, and then the router is connected to another router, for example.
Yep.
And you want to advertise the local area network and the network that these routers connected to the other router. Okay? So that all the routers learn about absolutely everything. And all the client machines can reach everywhere. That's what you want to do. But the thing is, these local area networks, they will never have a router inside. Never. Yeah? It's a local area network, so you have a switch and client machines. But the issue with this is, once you advertise the networks and it matches certain interfaces of the router will basically try to communicate using the OSPF packets that we discussed last week. Remember? Hello.
Yeah,
Yeah? What are the packets?
hello,
Hello.
Database
DBD, database description to describe the LSDB, link state request,
update,
and
acknowledge.
link state update, and link state acknowledgement. 5, yeah?
Yes.
That's how the routers communicate. So once you do the network command or once you do the advertisement in the interface itself, the router will immediately try to communicate with other routers on the networks that you just advertised.
It's like trunking protocol with switches that we try to establish trunking protocol and we.
Even though they won't be there,
Yeah.
it won't be needed. Yeah.
We stop it, yeah.
So it's pretty much the same thing here. We don't need the router to try to communicate with other routers in a local area network because you're never going to have another router in a local area network.
So you want to.
So, because of this, the router will try to communicate with other routers in the local area network. So the router will constantly be sending messages on the local area network. And this is what you get. Inefficient bandwidth, because the router is sending traffic where nobody's going to be listening to. Efficient use of resources, so the router is not efficiently using its resources because it's just wasting time and resources. And increased security risk. Do you know why this is security risk?
So someone can plug in a router and then.
Exactly. Yeah, listen to the
Listen to
OSPF
the-
packets.
yeah.
Oh, this guy's trying to communicate with me. Maybe if I just, configure router OSPF here as well, maybe I can learn the networks out there. And maybe then I can hack the network. So you see the issue here? Now, because of this, there is also another feature called the passive interface. So you make a router's passive interface every time the interface is connected to a local area network where you don't expect to have another router. Simple as that. Okay? And now you just basically mitigate the security risk because now the router is not going to try to send OSPF packets in the local area network anymore. Isn't that good? Sounds good. And it's not going to waste resources. It's not going to be inefficiently using the bandwidth now because it's not sending any message to the local area network. Alright? Is that clear? Oh, teacher, how do I configure an interface to be a passive interface? Super easy, mate. Barely an inconvenience. You go to the router OSPF that you have just configured, and then you type it in passive interface, and then you say which interface you want to make it passive. In this case here, I'm making loopback interface, because you know, why would you send hello packets or OSPF packets within a loopback interface? If the loopback interface is the router itself. Yeah? So you can make the loopback interface a passive interface as well.
So if you've got more than one piece in your network table, then you're advertising the networks, but some of those networks don't have any other routers on them, so you don't want them to communicate OSPF
Exactly,
information.
but they're still advertising the
So
networks.
then you're passive interfacing on the ones that you don't want it to send
Yes.
information on.
So I'm going to draw a network diagram here. I have one router here, another one here, and this marker is absolutely awful. Yeah? So we basically have these two routers here, point-to-point link. This one is connected to a local area network. This one here is connected to another local area network. Is that clear? Yeah? So this is 10.0.0.0/30. Right? This is .1, this is .2, and then you have a local area network here. Let me draw this. 192.168.1.0. Another one here. Alright? So basically I'm going to configure OSPF on these both routers, router 1 and router 2. Alright? So I'm going to configure router, OSPF, process ID will be 1, so router OSPF 1, and then I'm going to configure this to be advertised, right? Because otherwise these guys here, they cannot reach this. Because this router doesn't know about this network. Yeah? It's behind another router. So how does this router can get to know this network? By communicating with this guy will tell this guy, hey, I know a way to get here. And then this guy will say, okay, cool, I'm going to keep that in mind. Saves in the routing table, and now it knows how to forward the traffic to LAN A. Based on the passive interfaces that we just discussed, what are the passive interfaces here?
The ones that are connected to the LAN, the button ones.
So you can configure these one to be a passive interface, and
Yep.
because these are the ones connected to the local area network. Right?
They don't need the OSPF routing information. That's
Exactly. None of the devices here, they need to know about anything about OSPF. They don't care. Yeah? Same thing goes here. None of the devices here, they need to know anything about OSPF. They don't care. You don't have a router here at all. You expect to have N devices here and not another router. Is that clear?
Yes. What if we have a situation with a layer 3 switch? For example, does it changes everything? Does it communicates like any other router or?
So for example, if you have a layer 3 switch here,
Yeah.
Why do you
Any
come out
connection
of the
between
OSPF?
layer 3 switch and another router, let's say.
so the layer 3 switch can be configured to have routing functions. So
Yes.
you can configure the layer 3 switch to share OSPF routes as well.
Okay, yeah, that's what.
So it can basically act as a router as well.
Alright.
But if you have a layer 3 switch, which is just basically forwarding traffic between the internal VLANs of your internal network, it doesn't even need to be running OSPF. It just needs to have a default route to the router.
Yeah.
And it does the VLAN routing here. Remember?
Yes, yes.
Inter-VLAN routing
Yep.
with a layer 3 switch. Yeah? Is that clear? Or you can configure the layer 3 switch to share the routes using OSPF.
Yeah.
It's another option.
But you'd only configure the one interface that connects to the router, wouldn't you?
The way that I would do it
No switch port.
would be, I would configure the layer 3 switch to do the inter-VLAN routing between all the VLANs within the private network. And then I would create a default route in the switch, in the layer 3 switch, to the gateway router. So all the traffic going from the layer 3 switch to the router would be only the traffic to the outside world, which is not in any of the VLANs internally. Yeah? That's it done. So this layer 3 switch doesn't even need to know about OSPF at all. You still configure a passive interface here, done. Yeah? That would be the optimal. Is that clear? Yeah. Hey, I like this class. You guys are good. All right. Now, teacher, how can I verify that I configure OSPF in my router? Or layer 3 switch, if you wanted to do that. Show IP protocols will basically show you all the routing protocols that have been configured in the router. For example, OSPF that you have just configured here, using process ID 10. It will show you everything related to your OSPF router configuration. It will show you the router ID. It will show you the interfaces being advertised. It will show you if you have a passive interface or not. It will show you what are the routing information sources, which is just basically the other routers. Alright? So that is your show IP protocols. In the bottom, what is this?
The cost of OSPF.
Administrative distance of OSPF 110. What's the administrative distance for a directly connected network?
0.
What is the administrative distance of a static route?
1.
What is the administrative distance of OSPF?
110.
What's the administrative distance of EIGRP?
99.
You guys are good, huh? Alright, cool. And here we have router 1. We have another option for show IP OSPF interface gigabit 000. This will show you the OSPF information of the interface itself. If you go back, the show IP protocols is not showing you the things that are specific to the interface. For example, the hello timer. Every once in a while, the guys will say hello to each other. They are friendly neighbors. So every single day in the morning, Fred goes outside to take his newspaper and he says hello to his friend. Yeah? Living the Australian dream. Hey mate, good morning. And he goes back to his house. Next day he does the same thing. Goes there, grabs his newspaper. Hey mate, good morning. And this repeats the cycle every single day. Now the routers that are running OSPF, they do a similar thing. Every once in a while they send a message to each other. This is called the hello timer. Right? The hello timer for OSPF in broadcast networks and non-broadcast networks is 10 seconds. In point-to-point links, they actually are antisocial, so they don't usually talk to each other that often, okay? So for point-to-point and point-to-multi-point is actually 30 and 120. So it takes longer for them to talk to each other. Because, they absolutely know there's just one guy on the other side. They don't need to keep talking that often.
And Robert,
Shows up here in the router interface. So you see the network type, the hello and dead timers, and so on. Yeah?
so the bandwidth, on the link is not the criteria for the hello timer. It's only in ERGRP when it's 1.5.
Yeah, for OSPF, it doesn't matter. It's about the network type. For EIGRP, it's about the speed of the link.
Alright.
For EIGRP, if it's a slow link, T1 or slower, that means 1.54 megabits per second or slower,
Yeah.
that is
15.
extremely high. Okay? That is 60, 180.
Yeah.
60 for hello, 180 for hold. Because we don't call it dead for EIGRP, we call it hold. Hold timer. And for the high speed links, more than T1, more than 1.54 for EIGRP, it's 5 and 15. Okay? Is that clear?
Thanks.
Good.
Is there a verbose version? So can you do show IP interface OSPF 10 and then put a command, like an extra command to say that it shows the information for every single interface one by one?
Yeah, yeah. You can actually specify the specific interface you want to know information.
No, I know, but instead of having to write show IP interface gigabit this one, Ethernet whatever, or gigabit whatever,
Uh-huh.
is there a way of making it print out every single
Yeah,
interface?
yeah. Show IP OSPF interfaces.
Interfaces.
Yeah.
And then it'll
That
show
will do the job.
all of
You will
them.
show all of them. Yeah.
Great.
Cool. All the OSPF interfaces, all the interfaces that participate in OSPF process. So it is possible. Now we talk about these guys, the network type. Okay. We need to discuss why. Do you guys remember we discussed about the DI and BDR last week? Designated router, backup designated router. Why does that exist, man?
Just load balancing and reliability.
To make it a little bit more efficient, because we don't want to overload the network with a lot of traffic. So any updates will be sent only to the designator and the backup designator, and they will broadcast this to the other.
Propagate the information.
Yeah.
Yeah. So you basically want to make things more organized. Cool. So you're basically going to elect 2 representatives because you don't want all the routers to be exchanging information with every single one of them. Alright? So they will basically choose 2 representatives. Designated router and backup designated router, or DR and BDR. Okay? This is only if you have many routers in the same broadcast domain. It has to be clear. Because if you have a point-to-point, there's just one router on the other end. So why would you elect a DI and a BDI if you know it's just one router out there? So you don't do it. So you only do an election, DI and BDI, if you have a broadcast or non-broadcast domain, network type. That's when these happens. When you have a point-to-point, no need for doing that at all. We're not going to do that. There's no DR, no BDR in a point-to-point connection. Okay?
It's the same network then, isn't it? Because we've got many routers, you've got a switch in the middle, so it's actually just the one network.
Exactly.
Yeah.
That's what we call a broadcast network.
Yeah.
We represent it with a switch, but that's just representative. It's not necessarily how it is actually done. Okay? But that's representing a broadcast network. Okay? Is that clear? Yeah? Cool. The switch is actually representing something called MPLS network. Because that's how an MPLS layer 2 works. It works similarly to a switch.
It's a different device, isn't it?
Yeah. So check it out. So once we have a broadcast network, we have something that looks like this, right? A router there, router there, a router here. So we have router 1, router 2, and router 3. Cool? Every single one of them is connected to a local area network. And we represent this broadcast network with a layer 2 switch. But this layer 2 switch is just for you to understand how things work, because what is actually done here, this is actually an MPLS network. Usually a layer 2 MPLS network. Okay? But this helps you understand the concept. Alright? So once you have something called a broadcast network, such as this, broadcast network, that basically means this router can reach out to any of the other routers. Yeah? If it sends a message here, this message can be sent out to both of the other routers. Yeah? So you can easily communicate with both of the other routers. Now, once you have multiple routers within the same multi-access network, which is the same that we have here, these routers, they need to communicate with each other. So router 1 will send a message to router 3, router 1 will send a message to router 2, Router 2 will send a message to router 1. Router 2 will send a message back to router 1, and then router 3 to router 1, and then router 3 to router 2, yeah? And these are called the adjacencies. So they establish the adjacencies. Now, there is a formula. I think in the chapter you find something like this. Yeah? These are the number of adjacencies when you have a broadcast network that form according to the number of routers you have. So here we have 3 routers. So this would be 3 minus 1, 2, divided by 2. You need 3 adjacencies here if you have 3 routers. Yeah? If you look at this, this is a function that grows like exponentially. Yeah? So that basically means if you have 4 routers, what do you get? 4 times 3. And now you got how many? 6. If you have 5. 5 times 4.
10.
Yeah? And so on. So this grows exponentially. So because of this, we do the elections. So we don't have these many adjacencies. Because once we have the elections, the routers, they will only be adjacent with the designated router and the backup designated router. So they will only send notifications to the designated router and backup designated router. And these two will be able to propagate the information to all the other routers. Is that clear? Cool. So that's the purpose of having the DI and the BDRs. By the way, you remember last week? How do we elect these designated routers?
Browser ID.
There's a priority list. Just
Oh, yeah.
It's the highest ID, highest router ID.
Yeah, you can assign priority from
You
0
can
to
assign an
2.1.
OSPF priority, yeah?
Yes.
But if all of them have the default priority, what do?
The ID.
It's based on the router ID, the highest one. So the first is the OSPF priority. The highest wins. Second is the router ID. The highest wins.
And then is it a loopback address or something like that? Is there a third option?
Third option? No.
No, that's.
Oh, the route ID comes from the.
Comes from the loopback, yeah,
Anyway,
yeah.
so they don't need a third option.
Alright, exactly. Now how do I change this behavior of the network interface? You go to the interface, IP OSPF network, and then you can change this behavior. If you want to have a broadcast network, you're going to change this network type to broadcast. If it's a point-to-point and you're always going to have a router on the other end, you can make it a point-to-point so there are no elections. Alright? When is this useful? By default, a serial interface on the router is considered to be an OSPF point-to-point. The fast Ethernet, gigabit Ethernets of the routers, they are considered to be a broadcast OSPF network type by default. So that basically means when you only have 2 routers and you use an Ethernet cable to connect them directly to each other, you can change to point-to-point. It's going to save time, no elections. Yeah? It's going to speed up things because now you don't require elections at all. No need to worry about that.
And the time to
Job's done.
time to die will be longer as well.
Yeah.
So
But that's
all of
only-
that means less communication.
Less communication, less messages then. So, yeah. Alright, is that clear? Questions? Concerns? No? Now you can verify the routing table. In the routing table, how does a OSPF learn route shows up?
Oh,
As an O. It's an O route. Yeah. So you configure OSPF, 2 routers share information. The information that one router learned about a network from the other router will show up as an O route. OSPF.
So
Yeah.
now you've got 3 classes, right? You've got C, L, and O. Is that right?
C is for directly connected. L is for the local interface itself. O is for OSPF. Does anyone remember EIGRP?
D, dual.
G, because it uses the dual algorithm. BGP? B. Yeah,
Makes sense.
makes sense. Static route.
S
S.
and,
Yeah. Exactly. The only one that doesn't make much sense is the EIGRP. That they decided to use D. Yeah. That's the only one which is weird. You know, I think I found out why they didn't want to go with E for EIGRP.
What's that?
Because E is used for external networks in IPv6. E, external networks. So I think they are, no, let's just use something else. And then they went with D. It's a good guess. Alright, there you go. So, packet tracer, we're gonna do this together, mates. You know, because I like to smash things out. So grab your packet tracer activities. Point-to-point single area OSPF configuration.
We don't have access to it.
You should have access to it.
No, because I haven't done my test yet. I'll wait on that. Sorry, myself.
Alright. So if you guys haven't realized yet, for this week you have a lot of homework for you to do, mate. A lot of packet trace activities. So I'm just gonna download all of them here. And we're going to do the first one. Point-to-point single area OSPF. That one is super easy. Alright, let's mesh it out. This is way too large, mate. Font size. See if that's any better. Yeah, that's better. Mate, you know one of the features in packet tracer that I love the most that they included?
Doc.
The dock. Mate, that is so useful. Believe it or not, back in the days we actually had to do it manually. Drag and drop, you know, side by side, perfectly aligned, so we could do the activity. And now they just came up with this genius solution, mate. Dock the instructions on the side. Oh, I wish I had that a few years ago. So there you go. So we do have 3 routers here, router 1, router 2, router 3. Each one of these routers connected to a local area network. Router 1 connected to LAN 1. Router 2 connected to LAN 2. Router 3 connected to LAN 3. What we're going to do here is extremely simple, mate. We're going to configure OSPF on router 1, 2, and 3. Before we start, if I configure an IP address on the PC in LAN 1 and the PC on LAN 2, and I try to ping them, is that going to work? Why not, Fred?
So you just
So I'm going to configure an IP address here on this PC here,
Yep.
on this one here as well.
Yeah.
Can I ping between them?
The routers won't know the other networks where to send the traffic to.
Mate, remember this. The router only knows what it can see. What do you mean by what it can see?
Directly connected.
The things that are in front of it.
Yeah.
Okay? So the router knows about the things that are right in front of it. But it doesn't know about the things that are behind all the routers. Mate, this is the key for you to understand networking once and for all. Alright? Now, I'm gonna get rid of all of this. I'm gonna get the same network here. I'm gonna unplug this interface LAN 1 from router 1. And I'm gonna plug this interface on router 2. And then I'm gonna try to ping. Is that going to work?
Yeah.
So if I take this out of here, plug into router 2, and then I try to ping again, is that going to work? From LAN 1 to LAN 2?
Oh.
No, they're on a different network.
Wait, same interface?
You have to configure the computer.
It's pretty obvious here this is not going to work because this router can only reach these 3 networks.
It should work, I think, because it's like,
If I take this out of here,
Yeah.
plug into router 2, configure the interface of router 2 to this LAN, is that going to work then? A ping from LAN 1 to LAN 2?
I think it should work.
It will, mate. That's what you were doing for introduction to networks.
Yeah.
Yeah? You have just one single router, and then you can have one segment in a LAN, another one in another LAN. You can bring from one LAN to the other because the router knows about the 2 of them. Because the router can see them.
Yeah.
So effortlessly, man. You didn't even have to do anything on the router. Didn't even need to worry about routing protocols. Didn't even need to worry about routing table. It just worked. Yeah? Because the router knows about the networks that are directly connected to it. Here, it's not going to work, Alvin. Because now you have local area networks behind a different router. That's why this doesn't work by default. You have to go the extra mile. You have to configure the routing protocol so that this router can tell this guy, mate, if you want to go to LAN 1, come to me. This guy is going to tell router 2 and router 1, you two, if you want to go to LAN 3, come to me. And that's it. That's how things work. Now let's smash this out, mate. See what we have to do here. Configure router IDs, configure the networks, configure the passive interfaces, verify OSPF configuration. Let's mesh it out. In this activity, you will activate OSPF routing using network statements and wildcard masks. Configuring OSPF routing on interfaces and by using network statements, quad 0 masks. In addition, you will configure explicit router IDs and passive interfaces. Is that clear what you want to do? So let's get started. Part 1, configure the router IDs. How do we do that? Initiating the router OSPF process. And then typing in router ID. So we get started with router 1. Let's mesh it out. What do I need to do? What's the name of this mode? User mode, user exec. Yeah. So you can't do anything from here, mate. Yeah. It's like being in high school. You think you have the freedom, but you can't even drive. Yeah. And then you enable yourself. Yeah. So you go to school, you get a certificate for a diploma. Yeah. But you have no job. You can do certain things, but not all of them. Yeah. So this is your privilege, or at least you think that you are privileged. But then you get a job, so you go to global configuration mode. Now you can go out there, get a mortgage, pay it for the rest of your life. Yeah, you know, you have certain freedom. There you go. You're in global configuration mode. Now, what do I need to do here to activate OSPF for this router?
And process number.
Does it tell us to use 10? Okay, so we go with 10. So router OSPF number 10. How about the router ID now? Is that it, Andrew? Is that all, mate? Just like that? Ridiculous. Alright. Second router. What do I do? Enable conf t, router OSPF 10, router ID 2222. Is that it? Just like that, ridiculous? Okay. Router 3. Enable conf t, router OSPF 10, router ID. Is that it? So easy, mate. Yeah. Can't believe people are paying $200,000, mate, a year for people to do this. Do you believe this, Alvin? No.
Yeah, but it's like a few hundred routers in the small network.
But still, mate, this is ridiculous. Not that hard. All right. So let's go. Configure networks for OSPF routing. How many statements are required to configure OSPF to route all the networks attached to router 1? How many statements?
3 statements.
You have 3 networks, 3 statements. Yeah?
Layers and layers of old things.
The LAN attached to router 1 has a /24 mask. What is the equivalent of this mask in dotted decimal representation? You don't know that one, mate? Go back to Cert 3, Network Essentials, Semka rules, online, because he's now delivering just online. And yeah, do the whole thing again. What is the subnet mask decimal notation for /24? Cool. What is the dotted decimal equivalent of /30? 555552, right? Subtract the dotted decimal representation of the /30 mask from the to find the wildcard mask. So what's the wildcard mask of the /24? 000255 for the /24. And for the /30?
So dot 3.
0003. Is that clear? Happy? Configure the routing process on R1 with the network statement and the wildcard mask that are required to activate OSPF routing for all the attached networks. The network statement values should be the network or subnet addresses of the configured networks. So let's go, mate. It's just basically telling us to configure router 1 to advertise all of its networks. So I'm going to go to router 1, and what do I do here? I use the network command. The first one we're going to advertise, Shai, is LAN1. So I'm going to type LAN1 IP address.
Doesn't the router already know that though?
No.
Because it's got, if you configured the,
It knows, but remember, it's selective. You still need to tell the router what is the router supposed to advertise to the other people. The router is not going to advertise everything by default. You have to let it know.
is there a command you can just tell to advertise everything?
Yes, there is. With the all zeros. So if you go network, everything, the router will advertise everything.
Okay.
Alright. Now we're going to advertise LAN1. How do we do that? Network 192.168.10.0 followed by the, which is 000. Is that all? Area. Which is? If it's single area, which area should be?
0.
So, if it's single area, you don't have the choice, okay? Keep that in mind, because that's misleading. You'd be like, oh, if it's single area, I can go with area 1. No, okay? It's area 0, the backbone area, okay? The bare bones, the necessary area, okay? Is that clear? So we go area, done. So first one is done. How about the second one? Oh, look at that, mate, 22%. Already? That's given, mate. So how about the other two? Network 10110. What's the wildcard mask?
0003.
The LAN is 192.20.
What?
That's still router 1, isn't it?
It's router 1. So 10110 and 10114. Isn't it?
Oh, you gotta put it all the networks.
Yeah.
Right.
Area 0.
What else? Job is done. You want me to make a slide bigger?
No, it's just, I'm just saying, like, compared to what the slides were telling us in the thing.
Nice. Okay.
Is that better?
Don't worry about it.
Cool.
When
So
the-
router 1 is done.
Free network.
So let's go router 2 and do the same thing. So for router 2, what do I need to do?
Network.
LAN first.
192.168.20.000.255.
Area.
Area 0.
Network.
Network.
Is there a reason you use the wildcard mask instead of the subnet mask? Is it a calculation that does or something?
Just a convention.
Oh, right.
There are no benefits. You know.
I
What
think,
One's
man?
opening it up and the other one's shutting it off. But I don't know which is which.
I think if they do it because it's easier to type, they're just lazy.
Maybe. Maybe. Could be. I'm not too sure. Not too sure.
It's not something like for the landing thing or something, or?
Comes down to someone's decision, mate.
Yeah, right.
I wouldn't do it, you know. But someone decided to go with that. Now, one funny thing is that actually, but here's the thing, Rob. Depending on which iOS you're running, which iOS version, I think from 15 onwards, you can use the subnet mask and it will then convert it back.
Oh, okay.
And then if you use the subnet mask and you do a show running,
Yeah, yeah.
the router has flipped for you.
Yeah, right.
So you can still go with the subnet mask if you want, depending on the iOS version.
Yeah, right.
Because, you know, some people just found that annoying.
Yeah.
Alright, so what's the other one I need to put it in here? The 8. So network 10.1.1.8, router 3. Let's go. 30 0, 255, area 0. Network 10.1.1.4, 3. Network 10.1.1.8. Ooh, that one was incomplete. I forgot the area. Yeah. Done. Alright. Now, do you remember the command to verify the IP protocols?
Actual protocols?
Do I need this do here in the command? Do show IP protocol?
Doesn't do make it like sudo in Linux, right?
Yeah.
Why do I need the do? Why does the do exist?
You're in global configuration, this command should run on the privilege.
Exactly. To inherit the commands from the privilege exec, the verification commands, you need to include the do in front of the command that you want to execute in global config. And there you go. So check it out. We've got the 3 networks here. 192.168.30.0, area 0, 10.1.1.8, and 10.1.1.4. And that's all. This is all running OSPF process ID number 10. The router ID has been configured to 3333. Alright, so
Do we need to
power
pass
1 is
the
done.
interfaces?
Huh?
In a real situation, would we then have to pass in the interfaces?
Yeah, no, we're still going to configure the passive interface. So step 2, configure networks for OSPF routing using interface addresses and quad 0 masks. Oh man, we were supposed to do the same thing for all of them. So on router 2, configure OSPF using network commands with the IP addresses of the interfaces and quad 0 masks. So for router 2, we're not doing what we just did.
Right.
So what I'm gonna do is, I'm gonna remove that. I'm gonna do no router OSPF 10. Get rid of that. Then I'm gonna do router OSPF 10 again. And then we're going to
Wait, are you in the right one? Oh, yes, you are.
network. This is router 2, so 192.168.20.0.
Oh, the quad zeros, that's the, what we're talking about,
The
wasn't it?
broadcast.
Yeah, broadcast,
No,
yeah.
not broadcast, advisors.
So mate, it's supposed to be router 2.
I don't understand why they can't just say.
IP address of the interfaces. Oh, okay. So it's network. What's the IP address of the interface, man? How do I verify the IP address of the interfaces of the router?
Shall I
So
show
IP interface.
Show IP interface three.
So it's basically telling me to advertise just the IP address of the interface itself. And we're going to use the quad 0 because we want to advertise as just the interface address, not the network. So this is exactly what we're going to do. So router OSPF 10, network 192.168.21, and then quad 0, area 0. There you go. And then the other one. And then the other one.
That's just the interface, is it?
Yes, just the interface itself.
So why would you do that?
No, I don't know.
Fix packet tracer, right?
Just some packet tracer nonsense for you today. And there you go. And then configure OSPF routing on router interfaces. On router 3, configure the required interfaces with OSPF. Which interfaces on router 3 should be configured with OSPF? So router 3 needs to be configured using the interfaces command, not the networks. So I'm going to go to router 3 and get rid of the OSPF, start fresh. And then we're going to go to the interfaces. Interface. We need to find out what interfaces are there.
So this is demonstrating the 3 different ways of doing it.
Exactly. So we basically need to advertise gigabit 000, serial 010, and serial 011. Let's go. So we start with the first one. Interface gig 000, IP, OSPF, 10, area 0. Done. You're advertising gigabit 000 in the OSPF process.
So you're advertising the network, right? On that is attached to this
Yes,
interface.
exactly.
Oh, so that's what those LSUs are for, isn't it? So then the other round is saying, well, what networks on that interface?
So
You know, if you just tell it that, oh, sorry, just thinking out loud, you know, like it just,
that's all good.
because I'm just wondering what, because those link state updates, you know, like, I was wondering what, apparently the router's asking for more information.
We'll see about that. We'll see about that.
Yeah.
Check it out. So
Thinking,
I'm gonna advertise the other one as well.
thinking if it only knows the, it's only told the interface and it's got to ask for the network.
So check this out.
Yeah.
There is actually a way we can verify the link state database on the routers, so we can see what we're receiving from the other routers. So check it out. If I go to router 1, for example, I can just type it in,
IP, OSP.
do show IP OSPF database. And this will basically show all the advertisements that I'm receiving from the other routers. Check it out. So I'm receiving all the advertisements from a single area, area 0. This is my router ID, my process ID, and I've been receiving information from router 2 and router 3 about these networks, the 20.1, the 30.1, which is just basically the local area networks, LAN 2 and LAN 3, which have been advertised. So check it out. Show IP route OSPF. Oops. I'm receiving the first one and the second one. Yeah. So they're both here. And this one, I'm actually receiving this one. 10.1.1.8. I'm receiving this one from both routers because both of these routers, they know about these networks. Does that make sense?
Yeah.
Yeah. So I'm basically receiving this, and this. Why am I not receiving this in the routing table?
It's directly connected, it's not
It's
OSPF.
directly connected. So I trust myself first, and then I'll trust the others. Because the directly connected, they have a lower administrative distance. I already know how to get there. Yeah? Because they are directly connected routes. So they are not here as OSPF routes because of this. So they just not added to the routing table. Exactly?
They will be added to the routing table, but not under OSPF. You're just required for OSPF.
No, they're not added as OSPF routes.
Yeah,
That's what I'm saying.
Yeah, sure.
But they're gonna be there, yeah, as directly connected routes.
Yeah, alright.
There you go.
Yeah.
So one is the 10.1, which is this one here. And this is what we were discussing, Rob. One shows up as a network, which is
Yeah,
the,
no, it's the interface as it's.
and the other one shows up as the interface itself, the IP address of the interface. Exactly?
That's why it's 40.
So the IP address of the interface is an assigned IP address.
Yeah.
Right.
It's been assigned to the interface. This is the one.
We
So you can artificially assign that.
you need to manually configure it anyway.
Yeah.
You always need to manually.
Alright, what else we have to do here, mate? Configure the passive interfaces. Which interfaces on router 1, 2, and 3 are the LAN interfaces? This is
Serial one?
super easy.
Is it
Here,
serial?
here, all the gig interfaces.
Oh, they're the gig ones. Whichever one's
Gig
face-
000.
What's the command again? Passive.
The ones that face the LAN.
Exactly. So how do I do that?
That's it.
Mate, so easy.
Maybe just change the number a little bit.
On router 2, yeah? All done? On router 3, what else we have to do? Probably missing something still.
Did we assign router IDs? We did.
Forgot the router ID on router 2 and router 3. I think I've done that. Because I removed the OSPF.
Yeah. Matthew needs to win.
Naughty. Is that how I do it? Check it out.
Clear IP or
Yeah, you've got to actually get.
For this to take effect, otherwise it doesn't. So I'm gonna do it later. I'm gonna do router 3 first.
There's 192 interfaces, be the router ID, wouldn't it?
Router ID.
Have a look.
Yeah, because it was the router, one of the interfaces. Yeah. Check it out. Show IP protocols. Now it's the correct one. Yeah.
You haven't done clear router ID yet.
By the way, the clear IP OSPF process is a privilege exec. So you have to do this.
I think you'd actually log in.
And then you say yes. Done. The other one.
Oh, you do that after you change the router ID.
Exactly.
Yeah, right. And that's all you have to do.
Done.
1%? Oh, we won.
27.
Okay. Is that clear?
Yeah.
Do you remember the states? It's full state. Basically means it finished. It converged. Yeah. It found the best paths. It got the LSDB. Yeah. And then calculated the best paths for the certain networks. Is that clear? Questions about OSPF, LSDB, passive interface, pros ID, area, No? network command, interface command? All good? Designated router, backup designated router. Is that all clear? Yeah? Cool. So I got a few questions for you guys. You're gonna have to say if it's true or false. In OSPF, when we have a network type called a broadcast, we basically need to elect a designated router and a backup designated router. For this election, the designated router will be the router with the lowest router ID. Ah, you guys are smart. Now, I'm gonna ask you another question. In an OSPF broadcast network, the designated router will be the router with the highest router ID.
If you didn't assign
Unless
priority,
you
then
manually
priority is the same, yes.
assign it.
So because I said will be, it's wrong, mate. Because you don't know if the priority has been set before. Yeah. Now, I'll do an extra exercise for you here because there will be a backtrace you have to do later on to do this. Now, do we have a designated router here? Do we
No,
have a
don't
backup
have
designated router
elections,
here?
all point to point, right?
We assign it manually.
Do we
So
have
point to point,
designated router?
no.
We don't because it's all point-to-point connections. See here?
Yeah.
Point to point, yeah.
Ah.
So there are no designated router, no backup designated router in this example. But there will be another example you will do where all of them will be in a broadcast network. And then you have to play with the OSPF priorities to change who is going to be the designated router. Alright? Is that clear? So this one is done. So let's keep going. Because I still have to finish this stuff. Multi-access OSPF networks. We already discussed about this. This is a broadcast network type. That basically means every single one of these routers, they can communicate with each other. And because of that, they will establish neighborships with each other. But we don't want all of them to establish neighborships with each other. Because of that, we're going to have too many adjacencies with each other. We don't want to have that. We want to optimize things. How do we do that? Electing the designated router and the backup designated router. So all the other routers, they will only be adjacent with the designated router and the backup designated router. The designated router and backup designated router, they will then propagate the information from every single one of these routers.
So in this example, if you say they will establish only adjacency with the DR and PDR, if we will type the command to see the neighbor database, we will see only those two, the DR and the DBR,
Same to the DI and BDR.
the database of the neighbors, the adjacency database.
You will still see information coming from different routers.
Yeah.
But it's just going through the DR first and then,
But
you know
all
what I
the
mean?
other neighbors will show up in this database, right?
The advertisements will.
Yeah.
But they're going to the DR first and then being propagated to the
I
other
think it
routers.
adds information to the table.
Did you get it?
Yeah, so
So for example, if you have 4 routers, and this one is the DR, this one is the backup designated router.
Yeah.
Yeah? This one is adjacent with the DR, this one is adjacent with the DR, this one is the same thing, yeah?
Yeah.
So this guy will propagate the LSAs here and here.
Yes.
These LSAs will go to the DR and will come back to this guy. So this guy will still
Yes.
know information from this router.
Yes, but if you type on the, let's say on this router, the one of the lower ones, you type
Yes.
the command,
The
OSPF neighbor to see the neighbors list, the database. We have 3 databases, right? One of the is the neighbors database, the links to database, and the
Yes. So in the neighbors,
database. Will I see all the routers or just the DR and the BDR?
you will still see all the other routers.
Alright, yeah.
You still see that as drawers. So they'll still be there.
They will show up as DR order. Yeah.
So these ones are called the designated routers. These ones are called
DR order. Yeah.
drawer. Yeah, these two.
Yeah.
Still, if you show the neighbors, it's still gonna show all of them.
Alright.
But still, one, for example, if this router here needs to send information about this network, it's only going to send to the DI and the BDR, even though this guy's still a neighbor.
Yeah.
But it's just how the propagation of information works. Does that make sense? Alright, cool. Now you actually do an exercise, which is exactly this one here. Alright, and you'll be able to see that. Alright, cool. So what basically happens is, because of the fact that this guy will only send the information to the DR and the BDR, we need to create a multicast group for these designated routers. For when these guys, they send information, this information will only go to DR and BDR. So we're basically gonna have multicast group addresses. One of these are the 224.0.0.5. This is for the drawers. The drawers will join a multicast group called 224.0.0.5. So every time a DR or a BDR needs to propagate information, they will send to the destination IP 224.0.0.5, which all the other routers participate in. Oh, so there should be another multicast IP address for the DI and BDR, and there is, and it's this.
So they're reserved IP addresses then.
So every time a router needs to send information, so it needs information to be propagated in the OSPF domain, it will send to the multicast address 224.0.0.6. And every time the DR or the BDR needs to propagate this information to the other routers, it will use the multicast address 224.0.0.5.
But wouldn't the BDR be that 0.0.5 address as well?
No, it's in the 6. So
If
the,
the DR needs to update it, have to update the BDR as well, wouldn't it?
yeah, so these routers, they will send to the BDR and DR.
Oh, it's into both addresses?
Yeah, to both of them. So that's the thing, the BDR is pretty much a backup for the DR, so it's doing exactly the same thing as the DR. The DR goes down, immediately the BDR will become the DR. Immediately. So everything that the DR was doing, all the routes that the DR knew, everything will come to the BDR.
If one of the drivers changes one of the configurations, then it just uses the 0.0.6 address.
Exactly. It sends up. I like to think this way. Once the drawers need to send information, they will send it up to the designated routers. So I put the designated routers at a higher hierarchy. So they're like at the top of the food chain. So because they're at the top, the drawers, they need to send information to them. So they send to them using the 6 address. And then it goes down to the 5, to the other drawers.
Okay.
Seriously, man, I had to memorize these way. Because you will get questions about this. For sure. Alright. So it's gonna be like CCNA question. Which multicast address is used by the designated routers to communicate with the drawers? And then you have the options. 224.0.0.5, 224.0.0.6, 224.0.0.10,
And ERGRP.
224.0.0.9.
Good question.
RIP.
Great.
So you get all those options there, man. You know, of course, man. That's why people pay big bucks if you got your CCNA. You have to know these things. All right. Multi-axis reference topology that we're going to study is this one. Why is this guy the DR? Router 3.
Router ID.
Highest router ID. So considering that all IP/OSPF interfaces, they have the same priority. He's the router ID because it's got the highest. He's the DR because it's got the highest router ID. Is that clear? So with the show IP/OSPF interface, we can also observe what are the adjacencies being made. So this router is adjacent with two other routers. Which other routers are those?
That have designated routers.
The DR and the BDR, as we saw here. So the drawers, yeah, they become adjacent with the DR and BDR. All right. Now, if we execute the command on the BDR itself, we're going to be able that the BDR is still lists the DR here and the drawer still here as neighbors. They're still neighbors. It is just not sending the information to them. All right. Is that clear? All right, cool. Now these are the states. So once you execute the command show IP/OSPF neighbor, you can find out what are the function of your neighbors. If they are drawers, if they are designated routers, backup designated routers, or two-way drawers. Now these are the states, full or two-way. Full just basically means the router has already updated the link state database, has already calculated the shortest path algorithm, has already found the best path. Job is done. All right. Do you know what the two-way state means?
Still working it out.
The routers, they know about each other's existence, but they're still finding out if they're going to elect a DR and a BDR. They're still going to exchange the database description packages for the LSDB. They're still going to figure things out. So they know about each other. Now they're ready to exchange the LSDB, talk about it, and so on. So these two states are good, two-way and full. It basically means they are somehow communicating with each other. All right. With the show IP/OSPF neighbor, you'll be able to see the neighbors, the drawer, the DR, and there you go. Their IP address, the interfaces, and the dead time. Okay. How does the dead time works, mate?
Isn't it twice dead time equals really dead or something?
So for OSPF, the dead time is 4 times the hello time. So for broadcast, it's 10, and the dead is 40. Yeah. For EIGRP, it's 3 times. Yeah. Why consistency? So for EIGRP, 5 seconds for high-speed interfaces, and 15 3 times. Right?
Taking that out of the school.
Yeah, Fred, you have to know that. For OSPF, you have to know. For EIGRP, you don't have to know anymore. But if you already know, that's an advantage because it's in the CCNP.
On the CCP.
Yeah. So it's still in the future, mate. If you're still gonna be a network engineer in the future, it's still gonna be useful for you knowing that.
They don't teach that here, do they?
No, not anymore.
That's a shame.
Yeah. All right. Election is based on the following criteria. The first thing is priority. Priority is a value from 0 all the way to
255.
the default is,
1.
and you need to know that as well. Okay?
We saw it when in the previous slides when you saw the information about the 3 routers. We saw that priority is 1. This is why they chosen the router ID
As the election criteria, yeah.
Yeah.
Now, it's 0 all the way to 255. 255 is the highest value you can assign. If there are no other routers with 255, congratulations, you are now the DR. Okay? Now, if you set it up to 0, mate, what does
You don't take Not in
happens.
the elections at all.
Exactly. It's like you're not interested in politics at all, Fred. You are zero. Okay? Not interested at all. You're not gonna cast your vote because you don't care. Right? Alright, so what's the second criteria? Highest route ID. Done. Mate, I've been talking too much today. There you go. That's how you set the priority. Go to the interface and IP or SPF priority. Job is done. There is an activity for you to play with the DI and BDI. I'm not going to do this today because otherwise we're not going to leave this place very soon. Modify single area OSPF version 2. Now, in OSPF, how does a router find out the shortest path?
In OSPF,
Yes.
it uses the
The
algorithm.
best path.
Uses the algorithm after it gets all the information about all the other networks.
Uses the algorithm. So the algorithm needs to find out which one is the best.
Doesn't it just add
But-
them together?
How does it choose the best?
Bandwidth.
It's
and,
arbitrary.
That's right, hop,
You
hop,
tell it.
hop count and bandwidth together, isn't it?
Is it the 5Ks? No, this is the EHF.
Yeah, Jeff.
Everything's
Tell it as
For OSPF, man, it's just cost.
cost.
Just cost. And what is cost?
a number you
Fred.
input.
It relates to bandwidth. right?
Combination.
So
It's the inverse of the bandwidth. Inverse of the bandwidth. Once the shortest path algorithm needs to choose the best path, Mr. Alvin. It needs to choose the best path based on the lowest metric. Metric for OSPF is cost. Okay? Because it's the lowest metric and it's related to bandwidth, they did this to you, mate. They did the reverse of the bandwidth. So that the higher the bandwidth,
The lower the cost.
the lower the cost.
It makes sense.
Yes, that's why they did this. It's the reverse of the bandwidth, the interface bandwidth. Now the thing is, this would be really easy, man, if it was just this. But it's not. Because OSPF also uses something called the reference bandwidth. So if you're calculating the cost for OSPF, there is a formula. I know when I say formula, you get worried about it, but it's super easy. It's the reference bandwidth divided by the bandwidth interface of the interface. Oh, and what's the reference bandwidth? This is a pre-established value. And because OSPF was created in the 90s, someone thought that 100 megabits per second was a crazy high value. Okay, in the 90s.
Back then, yeah.
So they're like, oh, let's go reference bandwidth 100 megabits per second. And that should be enough forever. And it was not. Okay? As a consequence of this, for OSPF, if you have a gigabit interface, you have 100 megabits per second divided by 1,000 megabits per second. And you will get 0.1 frame. But the cost is pretty much an integer.
Okay.
So it rounds up. And then you have a fast Ethernet interface with the same cost as a gigabit interface,
That's not good, isn't it?
which is terrible.
Very bad.
Okay? It's not good at all. Alright? Because then the cost is the same. Now, lucky to us, someone found out that that was the issue and they created a command so we can change the reference bandwidth.
Oh, that's
So this is the command. Auto cost reference bandwidth, and then you can change it. So if you have gigabit interfaces on your OSPF design, auto cost reference bandwidth, and then you type the gigabit interface there, and that's it. Now your OSPF has the reference as the gigabit interface.
We put the interface name.
No, the amount.
Oh, or
In this note, I think it's in megabits per second. Yeah.
Ah,
So you will put it in 1,000. Yeah. 1,000 for gig and 10,000 for 10 gig. Yeah. So this amount here is in megabits.
Megabits, okay.
So 1,000 for gigabit interfaces or 10,000 for 10 gigabit interfaces. Is that clear? Yeah? And there is also another way you can change the cost manually on an interface. So if you think that you want to manipulate the costs by yourself, you can use the command IP OSPF cost, and then you put the cost there. That's it. Once you change the cost, check it out. If you change to 10,000, the reference bandwidth, now your 10 gigabit Ethernet will have a cost of 1. Now your gigabit will have a cost of 10. So you will now prefer the 10 gigabit compared to the 1 gigabit. Is that clear? So if you don't change, mate, the reference bandwidth, it's gonna be the same thing for OSPF. Doesn't matter, and it will make the wrong decisions. So that's an issue. Yeah.
Can't they just change it for all of them?
Change for?
Couldn't they just change the reference bandwidth for every single one?
They could, but they just didn't do
That
it.
would make it too easy.
Yeah, make too easy for you, know. Less stuff for them to ask in the CCNP or CCNA, you know. Less money. And there you go. The cost of an OSPF route is the accumulated value. This is important, mate. Why is this important? Because in this topology here, router 1 will learn about this network from router 2. Yeah? Router 3 will learn about this network and will also advertise it to router 1. Yeah? Does that make sense? Which way will router 1 choose to go to router 2?
direct.
Directly.
Directly? Why?
Because
Cost
one
10.
is cost 10, the other two legs, one is cost 10 and the other one is.
So it's the cumulative cost.
So it's 10
This
plus
will
10.
be 10, this will be 10, 10, 20.
Yeah.
Which one is lower, 10 or 20?
Yeah. But if those were 10 gigabyte links,
Then it would be better to go that way, right?
yeah.
This is exactly what you want. Yeah? So if this was gigabit, and this was fast, and you change the reference, yeah? Because if you don't change the reference, it's gonna be the same. So it's still gonna go this way. But then you change the reference to 1,000. Now, this is gonna be 1, 1, 2, and this is gonna be 10. Which one is better? 2. OSPF will choose the highest bandwidth.
But it ignores the shittiness or lack of shittiness in the actual router. Because the router.
Yeah, you know what's that?
processing speed of the router
Exactly.
is what-
It just doesn't matter if the router is horrible. Yeah. So that's one of the drawbacks of OSPF, which is addressed by EIGRP, because then you can have more variables in the equation. Bandwidth, delay, load, reliability. Delay would be related to the router. If the router is horrible in doing decisions, the delay would be higher. And then, yeah, you wouldn't choose that way. So it all comes down to what is more important to you, mate. Yeah? For OSPF, the most important thing is the bandwidth. Nothing else matters. Is that clear? Nothing else matters. There you go. This is the command to verify the routing table. We're now filtering just the OSPF routes. Okay. Hello packet interval. That is something you can change as well if you want, even though I don't recommend it at all. Okay. And why is that? Because for OSPF, the hello and dead need to match between all the routers. So if you don't change on all the routers, This will cause issues. They will not form neighborships.
Does it have to be 4 like default as well?
Huh?
Does the dead interval have to be 4 times the hello?
Yeah, it will be by default. If you change the hello, the dead will be automatically changed to 4 times that. Automatically
The
changed.
other way as well, if you change the dead, then the default, the hello will.
Yeah, so they're associated to each other. Now, one thing here, you know what happens in the IGRP? They don't need to match. Which is interesting, mate. In OSPF, they need to match. They must match. Otherwise, the routers will not form adjacencies. In EIGRP, they don't.
Is that a security measure or?
Mate, it's just a design choice. You know, it's a design choice. And you know something else, mate? That is why OSPF timers are called hello and dead, Fred. But EIGRP timers are called hello and wait. Hello and wait. Hello and hold. So which one is worse, to wait or to die, Fred? The one that dies is the one that is not going to work if it's not set correctly. Man, I get paid to make you guys remember these stuff. Alright. There you go. You can also verify the OSPF neighbors. Why is it not showing here? DR, BDI, and DRODA.
It's point to point.
Yes. There are no elections. If you see this dash here in front of the state, that means there were no elections. They haven't elected the DR or the BDR. Most likely because the network type has been changed and it's not requiring an election. Or it could be because it's not finished yet.
Although it's a gigabyte link, not a serial link. So
But you could still change the network
Yeah.
type
Yeah.
and then it wouldn't require an election. Yeah? Alright. This is how you change the hello and dead interval if you want to on the interface itself.
Don't do it.
Because the interface will say, don't do it. Okay?
But it's good for troubleshooting.
Yes. Good for troubleshooting. There is an activity for you to do it. Make sure you do on all the routers, because otherwise it doesn't work. Default route propagation. I think that's the last topic we have to discuss. Now, the default route is what, mate?
The last ditch
Or also known as the
last resort.
gateway of
Last
last
resort.
resort. It basically means
Yeah.
Google. Yeah? If you don't know, the teacher doesn't know, your friend doesn't know, your mom doesn't know, you Google it. Even though Google is first choice for everybody nowadays. Yeah? Just Google it. It's easier. Yeah? But the thing is, if the router doesn't know what to do with it, has no entry in the routing table, doesn't know where to forward the traffic to, the gateway of last resort or the default route is there as the last resort, mate. Alright? This gateway of last resort or default route is usually to the ISP. It's not in the enterprise network. It's not in the VLANs. It's not anywhere inside of the company's network. What do you do with it? Yeah? Ship it out to the internet. There you go. With the show IP route, you're going to be able to verify that. If you have done routing and switching or the new routing and switching called Switching Routing Wireless Essentials, you learn how to configure a default route. You guys remember that? Statically. You can statically create a default route. It's the all zeros route, pointing out to the ISP usually. There you go. Now, usually what you have is you have an OSPF domain and just one router is connected to the ISP. So how are the other routers going to know how to get out of there?
You have to propagate it.
You have to propagate it. Advertise it as well. How do you do that? There is a specific command in OSPF to do that. This command is the default information originate. It's not even here, what the heck? It's supposed to be here, man. Yeah, there you go. Default information originate.
Can you do that on any of the routes? You just do it once on one of the routers, do
It
you?
has to be in one router, the one that has the default route. That's it.
Does it come from?
Oh.
Only on the router that has the connection to the internet, the default route. And then this router will basically include this default route into the LSDB of every single other router.
Oh, okay, it'll tell them.
So you just do it in one router, on the exit router, on the ASPR. Remember the ASPR?
Yeah.
That's where you're gonna do it.
I have a question about what we see in the previous slide. So it's interface, the previous one?
Is it this one?
Yeah, yeah,
Or this?
yeah, this one. What
Yeah.
does it say? Interface? What does it say there?
Hello.
Default route without gateway. If not a point-to-point, may impact performance.
Yeah, I'm talking about the commands in the.
LO1, it's loopback one.
So loopback one, interface loopback one, and then you assign the
IP address,
Yeah.
address to the loopback,
Yeah.
that creates it.
and then you assign a last result to the loopback, so it won't go
Yep.
anywhere. It just will be
A black hole. Yeah.
No,
It's like a black hole.
black hole.
Yeah.
You're
It will
right.
just go to the loop. Everything will go to the loop back. Everything.
I think there's a little, there was a line on the thing saying it's only because when you're doing, because when you're doing the practice.
You usually not connected to an
you've
ISP.
You've only got two interfaces, and so they just sort of invent the loop back to, I think it's just,
To simulate.
so we can do the.
Yeah,
commands of it.
To simulate like, yeah, the connection to the outside world. All right, there you go. Now, once you propagate this default route on the ASBR, it will show up like this in the other routers. What's the difference?
External and the asterisk.
It's an external route.
Static external.
And you see that there is a number in front of it.
E2.
What the heck is that, mate?
Are you talking about the E2?
Yes. It's got an asterisk because it's a default route. That's why it got the asterisks. And it's got E because it's an external. And it has a number, 2. What does that mean? Is the type of external route. In OSPF, we have 2 types of external routes.
External area or from the same area?
No,
No.
it's something else. In OSPF, we have 2 types of external routes, type 1 and type 2. Type 2 will not consider the cost to the ASPR. Type 1 will consider the cost to the ASPR as well in the equation. But this is too advanced for you, don't worry. So just remember, it's going to be an OE2 route. Alright. Verifying single area OSPF version 2. These are the commands we use to verify our configuration. The interface brief will help us out to understand if the interface is up. Mr. Noah, if the interface is down, it will not be advertised. Even though you type the network command, if the interface is down, it's not going to be advertised. So you need to make sure the interface is up and up. How do you check that? Show IP interface brief. What is up and up?
The two ends of the link.
Is that because the interface is extremely happy? Yeah,
Plugged in and turned on.
it's up and up.
Or is it open?
Why do we have 2 things when we define the interface state?
I think it's something logical and physical, right?
One is physical, the other one is logical. One is for the physical connection itself, the other one is for the protocol configuration. So you can have up and down. You can have down, down. Have you ever seen down, up? And you won't.
That's hacking.
And if you see that, tell me, mate, because I don't even think that's possible. How can the protocol be up and you can communicate using the protocol, but you don't even have a cable plugged in? It just doesn't exist. So you have up, up, down, down, and up and down.
In the loopback, you'll also have the same.
The same thing, but the loopback, you see that the loopback is always going to be up and up.
Yeah.
When you create the loopback is the only interface that you are not required to type no shut in the router. Once you create the loopback, boom, up. Immediately, straight away. No need to worry about anything else. Is that clear? We also have the command show IP route to verify that the OSPF routes are being learned and installed in the routing table. How do they show up in the routing table? Oh. We also have show IP OSPF neighbors to verify our
Adjacency.
friends. Okay?
And whether it's point to point or not.
We have the show IP protocols to verify the OSPF configuration.
Yeah.
Yeah.
Everything.
If you have created the OSPF process ID, if you have the networks being advertised, if you have the passive interfaces, yeah. You have the show IP OSPF, which is going to show you the reference bandwidth. And you also have the show IP OSPF interfaces to verify the interfaces running OSPF and the area that they participate in.
But you don't configure the OSPF on each and every, you can, but you can also configure it on the router itself, not on specific interfaces, right?
Yes. But still, even if you use the network command, it's going to match the interface. And then if you type show IP OSPF interface, we'll show that that interface is part of OSPF because the network command matched the IP on the interface.
Okay.
Yeah. So it's still going to be there. Now, this is the example of the show IP OSPF neighbors. There you have both of your neighbors and the router ID of both neighbors, followed by the priority, the state, the dead time, the IP address, and the interface. By the way, this dead time is
Counting backwards?
countdown.
Yeah.
What happens if it reaches 0?
It's dead.
The guy is not there anymore. Yeah, it's dead. Okay?
It will drop it from the database.
But the thing is, when does it go to 0? If it doesn't receive a hello.
Okay.
Yeah? So the hello is happening every 10 seconds for broadcast networks, yeah? But you are waiting 40 seconds. If in these 40 seconds you don't get the hello that you're expecting, cut it down. Yeah?
So those hellos keep going even after convergence.
Even after.
Yeah.
Yeah.
It's convergent,
It's a self-landing thing.
All right, there you go. The protocol settings that we discussed and the show IP protocols. Show IP OSPF. It will show you the backbone area. It will show you it will actually show you how many times the shortest path algorithm has been executed. As if you care about that. And the reference bandwidth, the most important thing. All right? There you go, the show IP OSPF interface gigabit will show you the process ID and everything else, including the network type. Alright. There's a packet trace activity for you guys to do, single area. And voila, we're done. Module practice and quiz, there you go. Make sure you do your module exam, because now we have finished OSPF. It's done and dusted, mate. All good. Do the module exams for OSPF and the quizzes.
We're not doing OSPF version 3.
I'm gonna briefly talk about it next week, but it's just a brief introduction to it because, yeah, we don't have time. So it's just the basics that you guys need to do for OSPF version 3.
80% pass rate on those modules?
For the module exams,
Yeah.
for you guys,
Sorry?
90.
90% pass rate.
For you guys, yeah.
Sorry?
For you guys, yes. You're a good class. So, yeah. This is the first time, mate, I have excellent students. All of you guys, you know. Usually the class is not this good, you know. Check it out, we got Mr. Fred, you know. Mr. Fred, which was the second champion of the Cisco Network Academy competition last semester, mate. Fred was the second place all over the world. Yeah. In a few countries. Yeah, in a few countries.
And you haven't even done this course. How'd you manage that?
More luck than anything I did.
Yeah, that's great.
He's done really well, mate. Yeah.
Straight to your CCO.
Yeah, but
He got a trophy from Cisco, mate. A trophy.
Trophy. Yeah. Done the electronic badge on the rest of this kid.
Alright. Packet traces, guys. Module exams by next week. Smash it out. Next week we're gonna briefly talk about OSPF version 3 and then jump straight into something else.
Thank you.